Today we'll be graphing inequalities with two variables. To graph inequalities with two variables, we use the same rules. If we have less than or greater than, then it is a dashed line rather than an open dot. If we have less than equal to or greater than equal to, it is a solid line rather than a closed dot. So I'm going to graph this just like I would a normal line in the form y equals mx plus b. So if I look at it as y equals mx plus b, my b is 6, so I'm going to start at 6, and my slope is 3 over 1, which means I'm going to go up 3, 1, 2, 3, and over 1. Or I could go down 3, 1, 2, 3, and over 1. In this case, it is less than, which means it's going to be a dotted line, meaning the points on this line are not included in the solution. So I'm going to sketch it out and put arrows on it because it's a line. And then it is less than. Less than means to shade below the line. So I'm going to shade everything below this line. This means any point in this shaded region is a solution to this problem. So the point 1, 0 is a solution. The point 6, -8 is a solution. Any point in the shaded region is a solution. Let's take a look at another one. Let's look at negative y is greater than 2x minus 3. To do this, I have to solve for y first, which means I'm going to divide by a negative. Every single part gets divided by a negative. So then I have y. When I divide by a negative, I flip the inequality sign. So is less than negative 2x, negative 3 divided by negative 1 is a positive 3. So I graph it just like y equals mx plus b. I'm going to start at positive 3. Here's a slope of negative 2 over 1, which means go down 2 over 1. Down 2 over 1. Down 2 over 1. Since it is less than, it is still a dashed line. So I'm going to dash my line, which means the points on this line are not included. And it is less than, so I'm going to shade below the line. So any point in this shaded region is a solution. Let's take a look at this next one. Negative 3x plus y is less than or equal to 6. To solve this one, it is in standard form basically right now. I would add 3x to both sides. So that gives me y is less than or equal to 3x plus 6. I start at 6. I go up 3, 1, 2, 3, and over 1, or down 1, 2, 3, and over 1. Since it is less than or equal to, now it is a solid line, which means the points on this line are included. Then it is less than or equal to, so I'm going to shade below. So if I ask myself, is the point 0, 6 a solution? I look for 0, 6. It is on the line, but this line is a solid line, so therefore it is included. It is a solution. If I ask myself, is the point -4, 1 a solution? I look for -4, +1. It's not in the shaded region, so it is not a solution. If I look at 2, 1 over 2 and up 1, it is in the shaded region, so it is a solution. The key to doing inequalities with two variables is remembering whether it's a dotted or a solid line. And then also, if I divide by a negative, I must flip the sign.